example on the type non-homogeneous differential equation or differential equation of the form dy by dx is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c2. So this is the example of that type. Solve 2x plus y plus 3 dx is equal to 2y plus x plus 1 dy. So write this equation in the form dy by dx is equal to ax plus by plus c divided by a2x plus b2y plus c2. Okay. So write here x plus 2y plus 1. This term as x plus 2y plus 1. Write this term as. Then what is there are two methods to solve such a type of differential equation. So first, depend on this ratio. If a1 by a2 is not equal to b1 by b2, then apply this method. And if a1 by a2 is equal to b1 by b2, then apply this method. So in this example, a1 is 1 is 2 and a2 is 1. So 2 by 1 is 2 and b1 is 1 and b2 is 2. b2 means the coefficient of y. So b1 by b2 is 1 by 2 by 1 and 1 by 2 are not equal. So these ratios are not equal. And so we have to apply this procedure. So substitute x is equal to x plus h and y is equal to y plus k. And therefore dx is capital dx and dy is d capital y. Okay. And then we get the equation 1 reduced to capital dy by dx is equal to capital D capital Y divided by D capital X, because dx is what? D capital X, h derivative of h is 0. Similarly, so this apply this procedure, okay. That is substitute x is equal to capital X plus h, y is equal to y plus capital Y, capital K, y is equal to capital Y plus k, and then we have this procedure. So collect the coefficient of, so after substituting x as small x as x plus h, capital Y as capital Y plus k in the numerator and denominator. So we have, then collect the coefficient of x, y first. So 2 capital X plus capital Y plus 2h plus k plus 3. And then at the denominator we have 2y capital Y plus x plus 2h 2k plus h plus 1 or h plus 2k plus 1. So substitute x as x plus h, y as y plus k. We have this after collecting the coefficient of x, y, and then remaining coefficient in one bracket. Then choose h and k so that these brackets are equal to 0. We have to find the values of h and k from these two equations. So after solving this equation for h and k, we have h as minus 5 by 3 and k as 1 by 3. So just it write 2h plus k is equal to minus 3, h plus 2k is equal to minus 1, and then by using adding, subtracting, multiplying, we have this h and k. Okay. So after solving these two equation, we have h as minus 5 by 3, k as 1 by 3. So this procedure. After substituting, we have to collect this x, y term and then remaining terms in the one bracket. So we have to take this bracket as 0 and we have to find the value of h and k. And then the equation second becomes, after substituting the value of this bracket as 0, we have d capital Y by d capital X is equal to 2x plus y divided by 2y plus k. And now this is a homogeneous differential equation. This third is the homogeneous differential equation. This 2x plus y is a homogeneous function of degree 1. 2y plus x is a homogeneous function of degree 1. And therefore, this is a homogeneous differential equation. And now it's reduced, this given non-homogeneous differential equation reduced to the homogeneous differential equation. And now we apply the method of homogeneous differential equation to find the solution of this differential equation number 3. That is substitute y is equal to vx. So y is capital Y, x is capital X. So y is equal to vx, and therefore dy by dx is, by using u into v rule, v plus x dv by dx. So substitute dy by dx as v plus x dv by dx is equal to 2x, y as vx, y as vx. And then take x common, capital X common, and cancel that. We have 2 plus v divided by 2v plus 1. And then we have x dv by dx is equal to shift this v to RHS, and then take 2v plus 1 as LCM. We have this. We have v plus 2 minus v into 2v plus 1. And so after simplification, we have minus 2 in bracket v square minus 1. And now it is in variable separable form. So separate the variables. So collect the variable of v to LHS and variable x to RHS. So shift this term to LHS. So 2v becomes multiplied divided by v square minus 1, and this minus 2 remains in RHS, and then shift this dx, it's multiplied divided by x. Okay, so after separating variables, integrating both sides, so we have this. So integration of 2v plus 1 divided by v square minus 1 is by using integration by partial fractions. No need of partial fractions, just write 2v divided by v square plus 1, v square minus 1, that is separately divide this v square minus 1 to these factors. So 2v divided by v square minus 1, 1 divided by v square minus 1 dv is equal to minus 2 log x. So if you have to apply the partial fractions, then write v square minus 1 as v minus 1, v plus 1, and then find the factors. Okay, we can also solve this using partial fractions. 2v plus 1 divided by v square minus 1, integration by partial fractions, that is obtain the partial fractions and then solve. Or directly divide v square minus 1 to separate to this 2v and 1, and then integration of 1 by x is log x. And then in derivative of v square minus 1 is 2v. So by using the rule integration f dash x divided by fx, answer is what? Log fx. So derivative of v square minus 1 is 2v. So log v square minus 1 plus 1 half, and the rule is 1 by x square minus a square is what? 1 by 2a log x minus a divided by x plus a. By using that rule, we have this 1 by v square minus 1 square is 1 half log v minus 1 divided by v plus 1 minus 2 log x plus c1, and then 2 log v square minus 1 plus log v minus 1 divided by v plus 1 minus multiplying by 2 throughout. We have this step. Then log a log v square minus 1 bracket square. M log a is log a raised to m. And then apply the rule log a plus log b is log a into b. So we have log v square minus 1 bracket square into v minus 1, v plus 1. And this log minus 4 log x, after shifting to LHS, it's become plus 4 log x. And then now it is log x raised to 4. And therefore we have into x raised to 4. And is equal to log of c as the constant of integration. Here c1 is the constant of integration. So write 2c1 as log c, new constant. And then cancel the log of both sides. We have v minus 1 cube, v minus 1 cube because v minus 1 square and v minus 1 cube, v plus 1 v square minus 1. So what is its simplification? V square minus 1 bracket square. So v square minus 1 bracket square is v minus 1 plus v minus 1 into v plus 1, and then we have v minus 1 bracket square, and v minus 1 is v minus 1 cube, and v minus v plus 1 bracket square, and divided by v plus 1 becomes v plus 1. And then cancel the log of both sides, and then substitute this capital this small v as capital Y by x, because capital Y is Vx. So small v is what? Y by x. So substitute v as Y by x. We have this, and then take x as LCM. So it becomes y minus x. So y minus x bracket cube divided by x cube. Similarly, take x as LCM, y plus x divided by x. And this x cube into x raised to 4 get cancelled with this. So we have y minus x cube plus y plus x is equal to constant. And now this is what? This is the solution of equation number 3. Now we have to find the solution of equation number 1. For that, substitute this capital X as small x minus h, means small x minus 5/3 means small x plus 5/3. When substitute this capital Y as y minus k means y minus 1/3. So substitute these values of x and y as x plus 5/3 and y as y minus k means y minus 1/3. We have this. Substitute y as y minus 1/3 and x as x plus 5/3. We have this. This is the general solution of the given differential equation. So this is the method to obtain the solution of the differential equation of the type dy by dx is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c2 if this a1 by a2 is not equal to b1 by b2. But if a1 by a2 is equal to b1 by b2, then we have to apply the uh, another method. This problem is again of the same type, that a1 by a2 is not equal to b1 by b2. We'll discuss was the problem of the type a1 by a2 is equal to b1 by b2. So we'll solve this problem. dy by dx is equal to 2x plus 9y minus 20 divided by 6x plus 2y minus 10. So the given differential equation is of the form dy by dx is equal to this. So if you find 2 by 6, a1 by a2 is 2 by 6, that is 1 by 3, and b1 by b2 is 9 by 2. And so we observe that a1 by a2 is not equal to b1 by b2. So mention that first, that a1 by a2 like this, a1 by a2 in this equation, a1 by a2 is not equal to b1 by b2. And this equation is of the type reducible to homogeneous differential equation. So now we have to substitute this small x as capital X plus h, small y as capital Y plus k, and then dx is dx and dy is d capital Y. So the equation 1 becomes dy by dx is equal to 2, substitute x as x plus h, y as y plus k, and after simplification we have this. So here also substitute x as x plus h, y as y plus k, we have this. So we have 6x plus 2y, right here plus sign, 2y plus 2y plus 6h plus 2k minus k, and here we have 2x plus 9y, 2h plus 9k minus 20. Then we choose this h and k such that these bracket are equal to 0. 2h plus 9k minus 20 is equal to 0. 6h plus 2k minus 10 is equal to 0. So solve these two equations for h and k by using either calculator or by using your usual method, that is cancel the one variable by h or k by using multiplying and adding these two equations, subtracting these two equations, we have this h as 1 and k is 2. And then the equation second becomes d capital Y by d capital X is equal to 2x plus 9y, 6x plus 2y, because these value of these brackets are equal to 0. And now this equation number 3 is a homogeneous differential equation, because if you observe this 2x plus 9y, it is a homogeneous function of degree 1. 6x plus 2y is a homogeneous function of degree 1, and therefore this is a homogeneous differential equation. So this given is non-homogeneous differential equation. After substitution, x is equal to capital X plus h, y is equal to y plus k, it's reduced to homogeneous differential equation. Now we have to solve this homogeneous differential equation. Now substitute y is equal to capital Y is equal to v capital X, and therefore dy by dx is equal to v plus x dv by dx by using u into v rule derivative. V derivative of x is 1 plus x derivative of v is dv by dx. Then substitute these values in equation 3. So we have v plus x dv by dx is equal to 2x plus 9, value of y is vx, and here value of y is vx, and taking x as common and cancel from numerator and denominator, we have 2 plus 9v, 6 plus 2v, and then shift this v to RHS. So x dv by dx is equal to 2 plus 9v divided by 6 plus 2v minus v, and so x dv by dx is equal to by taking LCM 6 plus 2v, 2v plus 6 here, right? It is not x, it is 2v plus 6, and what is the numerator? Is 2 plus 9v minus v into 6 plus 2v. So after simplification we have this 2v square minus 3v minus 2 divided by 2v plus 6, right here, 2v plus 6, okay? And then separate the variables, because it is in a separable form, variable separable form. Separate the variables. So shift this term to LHS, it becomes 2v plus 6 divided by 2v square minus 3v minus 2. Remain this minus sign to LHS. Then shift dx, it's multiply and divide by x. So minus dx by x, after shifting to LHS we have plus dx by x is equal to 0. So integrating, after separating the variable, we have to integrate both sides. We have this. So integration of this C1 as a constant of integration. And then integration of dx by x means 1 by x is log x. Now we have to find the integration of 2v plus 6 divided by 2v square minus 3v minus 2. And this integration is by using partial fractions. So similar to the previous problem, in the previous problem, there is no v term in numerator, denominator, because v square minus 1. That's why we have this method. We can also integrate this to v plus 1 divided by v square minus 1 by using partial fractions. That is, factorize this v square minus 1 as v minus 1, v plus 1, and then apply the method of partial fractions, integration by partial fractions. But here we have to apply that method. It is now compulsory to apply the partial fraction method to this problem. So we have to first factorize this 2v square minus 3v minus 2. So what is the factorization? This minus 2 into minus 2 is minus 4. So we have to find the two numbers, minus 4 and plus 1. Minus 4 and plus 1, addition is minus 3 and multiplication is minus 4. And then take 2v as common. So we have v minus 2 in bracket, and then this v minus 2. Then take v minus 2 as common. So 2v plus 1. And so this is the factorization of this denominator. V minus 2, v plus 2v plus 1. And then write it as a by v minus 2 plus b by 2v minus 1. And then take LCM and take the equation that 2v is equal to a into 2v plus 1 plus b into v minus 2. And then substitute v as minus 2, v as plus 2, and v as minus 1 half. What is the roots of v minus 2? From v minus 2 we have v is equal to 2, and from 2v plus 1 we have v is equal to minus 1 by 2. So substitute the value of v as 2 and v as minus 1 by 2. We have a as 2 and b as minus 2. So after substituting these values in this equation, we have the partial fractions of this factor are what? 2 divided by v minus 1 and minus 2 divided by 2v plus 1. So these are the partial fractions of this factor. So now the next step, we have to integrate. This 2 is constant, and 1 by v minus 1 integration is log v minus 1, v minus 2. Integration of 1 by v minus 2 is what? Log v minus 2, because this 2 is constant. This 2 is also constant, and the integration of 1 by 2v plus 1 is what? Log 2v plus 1 divided by 2, and then this 2 and divided by 2, it cancels. So 2 as it is, and the integration of 1 by 2v plus 1 is what? Log 2v plus 1 divided by 2. By using the rule integration 1 by ax plus b. What is the integration of 1 by ax plus b? Is log ax plus b divided by a. So this 2 and divided by 2 cancel, and then integration of 1 by x is log x is equal to log of c as constant, and then use the rule log m log a is log a raised to m. So it's become v minus 2 bracket square, and then use the rule log a minus log b is log a by b, and log a plus log b is log a into b. So we have this as log v minus 2 bracket square divided by 2v plus 1 into x into x into this v minus 2 bracket square divided by 2v plus 1, and cancel the log of both sides. We have this, cancel this log. So write here either log, here write log of this, and then cancel the log of both sides. We have this step, and then substitute this v as capital Y by capital X. This resubstitute this v as capital Y by capital X. So similarly here write capital Y by capital X. It is not small y. Write v as capital Y by capital X plus 1 is equal to c. And then the next step is what? Taking x as LCM, y minus 2 bracket square divided by x square, and x square and divided by x square divided by x. Here also we have the x as capital X as LCM, 2v plus x, and then x get cancelled. So we have y minus 2x bracket square, right? Capital Y, capital X, and then divided by 2y plus capital X. Here write y, 2y plus x, and then we have y minus 2x bracket square, 2y plus x is equal to constant. Okay, and then substitute this capital Y as and capital X as x minus h, that is x minus 1, capital X as small x minus 1, and capital Y as y minus k means y minus 2. So substitute that the values of x and y, capital X and capital Y, we have this as the final solution. X is equal to capital X is equal to small x minus 1 and capital Y is equal to small y minus 2. And this is the required solution. So these are the problems on the type reducible to homogeneous differential equation, or it's called non-homogeneous differential equation, if the ratios a1 by a2 is not equal to b1 by b2. In the next lecture, we'll see the problems of the same type, the type dy by dx is equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c2, if but the ratios a1 by a2 is equal to b1 by b2. So solve these problems of exercise of the type non-homogeneous differential equation. So we will see the remaining problem in the next lecture.